Hello everyone, let us start with question number 15 uh, from GATE 2023 mathematics paper. So I'm having a set D and function from D to C. We define that f of z equal to this and consider the following: f has three zeros in D and f has one zero. Okay, this is the question. So we have to just recall the Roche theorem. What is Roche's theorem? Suppose two you're having a function, say f of z. Or yeah, you're having two functions, say f of z and g of z. You're having two polynomial, and you are having one more condition, that f of z plus g of z, the cardinality, that sorry, not that is modulus, it is less than equal to mod of g of z, then number of zeros in some d, in some domain. If this is what this is what the condition is satisfied, the number of zeros in g of z is same as number of zeros in f of z plus g of z. Now look at this, how we are going to apply this theorem here, Roche's theorem. I'm having this as function. What I'm thinking to consider this guy as my g of z. So what is my g of z here? It is, say, minus 25, or you just write 25, that is also okay. 25 z cube. Okay, so this is your function. Now what do you observe? What is the observe your function? Yeah, and what is your f here? F, the other parts are your f. That means this f of z plus g of z here is my this whole function. Okay, it has this part which is my g of z and another part which is my f of z. Okay, and now what, whether they are satisfying the conditions or not, let me just rough this. And now look at this. What is mod f? I'm having, what is mod f? F of z. And in this domain, suppose in the domain D where mod z is less than 1, if mod z is less than 1, then mod f of z is what? Z minus 25 z cube plus z raised to 5 upon 5 factorial minus z raised to 7 upon 7 factorial plus z raised to 9 by 9 factorial minus z raised to 11 by 11 factorial. So what I have to do first, I am deciding what is my g of z here. G of z is, I am taking minus 25 z cube, or just take 25 z cube, there is no problem. So what is mod of f of z plus g of z? This is the other part, that is z minus z plus z is to 5 upon 5 factorial minus z raised to 7 upon 7 factorial plus z raised to 9 upon 9 factorial minus z raised to 11 upon 11 factorial. This is what your f of z plus g of z is. And what is and what do you know? Your mod z is less than 1. Correct. So this part can be, you can quickly find that this part will be mod will be going everywhere. So I'll be having 1 plus 1 upon 5 factorial plus 1 upon 7 factorial plus 1 upon 9 factorial plus 1 upon 11 factorial, something this I'll be getting. But what do I know about your g of z? Look at your g of z. G of z is 25 z cube. So what is mod of g of z? Mod of g of z is less than equal to 25. So this part, this whole thing is less than equal to mod g of z. So what can you conclude? This guy, f of z plus g of z, or the function f of z, have the same number of root as a g of z is actually. So what do you observe? Your g of z has 3 roots. That means your function f will have 3 root in this domain, and that is your first option, which is correct. That means your function has 3 root. As I told you that I am looking for this guy, and I observe that this guy is having the greater modulus than the other part. So the number of roots of this function will be same as number of roots of this guy who is having higher modulus. Okay, perfect. That means P is true. This is true. Now let us try to find Q. See, I have the Roche's method for this type of function. Mod z is less than some r. Okay, for this type of domain, I am having that condition. What I am going to do, I am going to break this domain into two part. The first part I am going to take uh, mod z is less than half, and second part I am going to take mod z is less than 1. So I already know that number of roots between mod z is less than 1. There is three zeros. Three number of roots are there. Three zeros are there. Okay. And I just have to find if mod z is less than half, then how many number of zeros are there. Okay. So that if because mod z less than 1, it contains this also. So if I subtract this guy, so this is key. So the answer should be 3 minus k. That should be the answer for this. Okay. Now look at the statement Q. It says that f has 1 0. 1 0, that means what? This 3 minus k should be 1. That means what is the value of k? K should be 2. Yes or no? That means k should be 2. That means this guy mod z is less than half. Number of zeros should be 2. But do you observe, is there any degree 2 term here? There is no degree 2 term here, so I won't get because see, a number of roots I will be getting either 1 or 3 or something like that. I won't be getting degree 2 because there is no degree 2 term here. As per the Roche's theorem, I cannot extract that degree 2 polynomial because I don't have any term. So this k cannot be 2. But as per this option Q, what does it says? F has 1 0. If it has 1 0, that means this 3 minus k should be 1. How did we find this 3 minus k? We just find mod z less than 1. That will contain all from 0 to 1. And then we found mod z less than half, which I am saying some k. So the answer should be 3 minus k. But to have this as 1, our k should be 2, which is not possible because there is no degree 2 term, so this is false. So which option is P is true? Option A is the correct one. Okay, thank you so much.